All right, so hopefully that gave you some good idea about how these roof structures are put together, the nomenclature as we saw, and the video shows some sections. So you have a good idea of how they look like once assembled. So what I would like to do now is to go to the course project and estimate some of the metal structures that we have over there to see how that can be done. In the content section of the website, in division part 2, I have added these two files, metal frame cost data and roof assembly cost data. Okay? The metal frame cost data will give you the cost of the components. Okay? So, for example, if we see here, you can see some of the numbers and letters that I showed before, like 20K5, 20K9, 22K5, and so on. So what we need to do now is identify those components in the project, count them, and then estimate their cost. So let's go ahead and open the course project and see where is the information about the metal frame. Come on. Okay, there you go. Oh boy. Yeah. So here we go. Where can we find information about the structural frame for this building? Any idea? Construction? Structural. Okay, very good. So we can go to the index of drawings and look here, structural. There is a foundation plan, section plan, roof framing plan. So S2 will give us the roof framing plan. We want to go over there and find S2 and then look. This is what we will find. This is the roof framing plan. It has some important notes. We want to read these notes. The elevation shown, it's a reference to elevation 00. That's the ground floor slab. We saw that elevation in Tuesday when we were looking at the height of the masonry wall. And then here's some explanation about the letters they're using. So L1 indicates an L 3 by 3 by a quarter. What is that? What is an L 3 by 3 by a quarter? I'm sorry? It's an angle?
3 by 3.
It's an angle. An L that has 3 inches on the bottom, 3 inches on the other side, and the thickness of that L is a quarter inch. Okay? So that's what it means. Then we have L2, then we have L3, and so on. So we want to get familiar with that, find where those L's are, and what will be the cost of those elements. So if we go here, we see they have these L1s, right? They have L1 here, and then they have these perpendicular rows, right? This indicates rows of L1, quarter inch by quarter inch, no, 1 1/4, 1/4 by 1/4 by 1 1/4 by 7/16 at 8 feet 2 inches spacing. So these are spaced at 8 feet 2 inches each, okay? They're running this direction. And then we have these L1s that are running right on the border of this wall, okay? So we want to estimate these L1s, okay? What type of condition will you use for L structure? Do you know? You can do by piece, yes, or you can do by length. Here we don't have we can't see where the pieces are, but we know that these L1s will be running all along this perimeter, right? So we can estimate the length and then find the cost per foot. So one way we could start with these L sections that we have here. By creating a new condition. This is going to be a linear condition. I can call this condition L1, okay? And then in the notes, I can write down the detail for the L1 as presented down here. So this is a L 3 by 3 by 1/4, okay? Fastened to concrete tie beams with 5/8 diameter Hilti bolts or engineer approved substitute at 1 feet 8 inches center to center, max spacing min, I don't know what that is. But we know how separate the bolts are to fasten that L to the wall. So we go ahead and we have L1. The thickness, what will be the thickness of this angle? The thickness, it's 1/4, right? Now the thickness that you will see on the drawing is going to be the width of the L. Okay, so in this case, it's going to be 3 inches. Okay? That makes sense or no? Okay. Let me explain that real quick here. The L is going to look like this. Okay? So if you look in perspective, this goes somewhere like that. All right? So this section here is 3 inches. This section here is 3 inches, okay? And the thickness of this wall is 1/4 inch, right? Yes? Now, when you create a linear condition in on-screen takeoff, when it asks for the thickness, it's asking for the width, okay? So it's going to be asking for how wide that drawing will look like. Because this is a 3-inch L, we want to have a 3-inch thick line. Okay? Is that clear? Yes? Okay, good. So that's why I've entered 3 inches in the thickness, and hopefully the line, when I start doing the takeoff, will be 3 inches wide. So I start here, hold on a second, let me go ahead and finish this part. So I measure a small portion, and the width of this line should be 3 inches. Now, questions? Yes, Prabhu.
Not a good idea to put the height as a 3 inches?
Well, the question is it a good idea to put the height as 3 inches? Yeah, you can. What benefit you get with that is that the benefit that you get by providing the height and the thickness is that if you want, you can get a quantity too that would be let's see, single end, all sides, both ends, single end, single side, both sides. Both sides will be this too. Well, because the L is, in this case it's symmetrical, it's a 3 by 3.
Yeah.
You can use both sides or one side and then multiply it 2.
No,
That's
the
fine.
reason I said that because since you're gonna go back and recheck yourself before you submit your bid,
Mhm.
when you see that thickness 3 inches, it's gonna throw you off and you said, oh, I made a mistake.
Right.
You know?
That's why in the notes
Yeah.
we write 3 by 3 by a quarter. So then when you go, I'm going to apply that. When you go here to the takeoff, and now you see this L1. The L1 is 3 inches high, okay, 3 inches wide. I think it will say somewhere. No, it doesn't even say the width. It only says the height.
I have your note.
Right, but on the note, I see that this is an L 3 by 3 by a quarter. So then when I want to go ahead and price that or buy it, I know what type of structure it is. Okay, so we have the L measured over there. As usual, after we do the takeoff, we want to go ahead and work on our estimate, right? So we want to go in the in our estimate sheet, create an on-screen takeoff data, may do one for metals, okay? And then we can just copy this L1 that we have created. Here, we copy that, paste that in Excel, and now we have a placeholder that relates the type of L that we're using. It's 3 by 3 by a quarter, and this one so far we've measured 16 feet long. Everybody follows that? We did this before with the masonry wall, so should be similar. Yes?
When you go back to on screen and just continue on estimate, does it
Right.
go back and
Okay.
to Excel?
This is the image that I have, right? And I am going to measure L1, right? That's L shape, 3 by 3 by a quarter. And I know that runs on the perimeter of the building, right, to support the metal structure. So I created a new condition, a linear condition, and I call that L1. So in that linear condition, I set the height to 3, the thickness to 3, and then what I am really interested is in the length of that L structure, okay? So in the notes, I wrote down L 3 by 3 by a quarter to make sure that I remember when I look at the takeoff, what is that L, how does that L looks like. Then what I did is I started measuring these L, and I'm going to just select that here and go all the way to the end. So I'm just measuring that section and assuming that I have L1 all over the edge of that building. So now I have these at 95 linear feet, okay? And what I did is I went to Excel. I created in the OST data on the tab where I am importing the information, I created a new line for metals, okay? And I paste over there the information that I got from on-screen takeoff. At that point, I had 16 linear feet. Now we have a longer measurement. So I go to on-screen takeoff. I go to the takeoff tab. Okay, I select L1, just drag across the mouse. Okay, when it's blue, I right-click on it, copy. Then I go to the Excel file. I mark the cell where I want to paste it, and then just click paste. So now the length is being updated to 95 linear feet that I have measured in on-screen takeoff. Okay? So now I have the placeholder in Excel that holds the information I am importing from on-screen takeoff. The next step would be figure out the cost, right? So for the cost, I have these metals line here, which unfortunately I don't think it has the L structures. No, I only copied the metal joists. So that's, I would need to find another source of information for the cost of the L's, okay? Now, let's see the joists. So we have, here's the image that we have, and now we see that here we have these types of, these joists. We have 20K5, 22K5, 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 right? So those are joists, similar to the ones that we saw in the video, okay? If we go to the cost table here, we see 20K5, 22K5, 22K9, and so on, right? Yes? So now we have identified that there is a structural member that's listed on the drawings, and it looks like this. It's an open web, and we have the cost per linear feet, materials, labor, equipment, and what else is in there? But bare cost and including profit. So we have, for each one of these members, we have the crew that we need, how many they can install per day, how many labor hours it will take to install one unit. The unit of measure is linear feet, and then we have the cost of material, labor, equipment, and the total. So because the unit of measure is linear feet, what type of condition do we want to create in on-screen takeoff? Linear, right? So we want to create a condition that matches the same name of that structure, and then measure that. Okay, so we have, that's not completely true. How do I fix that problem? Well, that's just costed by linear feet. In reality, you're going to do is per item. You're going to take the length of that piece, and you're going to order one piece with that description and the length that you want. Okay, and that's how you will buy them. But for now, let's continue with the linear feet concept. So I'm going to create a new condition, linear condition, okay? I am going to call this linear condition 20K5, okay? 20K5. And then I'm going to start measuring these 20K5. This one will go from here. It looks like it will stop here. This is 20K4, so this will be a different section. This goes 24K7, so that's a different section. So I have this 20K5, okay? Apparently I have only one that goes from here to there, and the length of that is 33 feet. Yes? So now again, I'm going to go to the takeoff sheet. I'm going to copy this 20K5, okay? And I'm going to paste that in my Excel sheet. So now I have the 20K5, and this is telling me it's 33 feet long, okay? So now I can go ahead and, because I'm going to use RS means, I go to the RS means table that it's blank. I'm going to make a copy of that table at the end of the file here, and then I'm going to rename that one to metals metals, RS means. Okay? So now I am going to start filling this table with the information that I get from the RS means. So if we go back to the RS means, I see that we're going to use this 20K5. Okay, so the line number that we will be using is 05210-600-0500, right? So it will be 05210 600 0500. And that would be a 20K5. Okay. So I go to Excel, I go to the code, and I enter 05210 600 0500 20K5. Okay, the description is going to be a 20K5 open joist. Okay, the crew I need is going to be E7. Okay, so I have crew E7. Daily output is 2000, 0.40, so this is 2000, this is 0.40 or 0.04, that 0.04, 0.04. Linear feed 535. Material is 1.58. Oops. And the equipment is 0.80. Right? So that's my unit cost in terms of labor, material, and equipment. All right, the total cost. And what is the quantity of work? The quantity of work is what I measured from on-screen takeoff that I imported and pasted in OST data. So I am going to click here, equal, go to the on-screen takeoff data, and select the linear feed that I have for the 20K5. Okay? When I press enter, then this number is now linked to the measurement that I will do in on-screen takeoff. So if I move to the right, we can see that the labor cost is now 176, right? Which is 33 times the labor cost, 535. Then we have the material 5214, which is 33 times 158. And the equipment cost 3540, which is 33 times 0.80, for a total cost of 255. Is that clear? Yes? Okay. Very good. So you guys think that you will be able to replicate what I have done here for the rest of these steel joists? Good. Excellent. So that will be the homework that we will have for Tuesday. I want you guys to have the masonry walls as we did last Tuesday, and I will specify at least a section where you need to do the takeoff and cost for the metals in this roof structure. Okay? Plus, of course, everything that we have done up to this point. Okay. I will do a homework for next Tuesday. Okay? That homework is going to include the walls that we measured last Tuesday plus metals that we're doing today. Okay? So I am going to ask you to have the walls as we did Tuesday and a section of the metals that we did today. And I will specify, the scope of work. You're not going to do the whole project. I will probably ask, from the first column to here. I don't know. I'll figure out something, but it's going to be a section. So it will be very clear what area I want you to estimate. Okay? Any questions about that?
Yes,
Yes. What's your question?
for the L1,
Uh-huh.
when we was looking at the RFPs and it wasn't there, would you be able to put that paper up or?
Well, you can look I am not going to post all the costs for all the project items. You will have to find some of them by yourself. Okay? I will normally post the ones that I'm using for my examples. So the answer is maybe.
Maybe?
Yeah, because I use it as an example, so maybe I will post it.